Hello guys, my name is Shreyas. I'm an educator at an academy. You can follow me on the learning app as well. You can see my set of courses as well as other set of courses by the awesome educators on the learning app as well. So please do install it. And this is a lesson about the water turbines based on the course Turbines, Engines and Pumps. So if you like it, please do rate it, review it and share it. And please do subscribe us on our YouTube channel, that is the Unacademy Engineering Students. Thank you. So guys, let's move on with our course Elements of Mechanical Engineering. I have given my intro already. I am a BE Mechanical Engineering student. You can follow me at the Unacademy user platform which is mentioned over here. So Turbines, Engines and Pumps is the course we'll be dealing with. So the target audience for this slide will be engineering students, general audience who are interested in mechanical entities, people who are interested in machine related mechanisms, and automobile enthusiasts. So the learning outcomes of this slide or after this lesson will be, you guys will come to know the classification of hydraulic or water turbines, the principle and operation of a Pelton wheel or a Pelton turbine, the principle and operation of a Francis turbine, as well as the principle and operation of a Kaplan turbine. So let's start with the lesson, the water turbines. So before going on into our lesson, let's have a quote. Water is the driving force of all nature. Correct quote, right guys? So let's move on to our lesson. So water turbine is actually a hydraulic prime mover which helps in the conversion of energy of the falling water into the mechanical energy in the form of the rotation of the shaft. The mechanical energy in turn it is actually converted into electrical energy by means of a electric generator. Different types of water turbines, they have been developed with the increasing in need of power. The principle of working of the three major types of turbines will be clearly dealt in the coming 4 slides. Generally, the water turbines, they consist of a wheel called runner or rotor. A number of specially designed buckets or blades or vanes are fixed around the periphery of the runner. It is made to rotate by either by a single or a double or multiple jets of water or by flow of water. If a generator is coupled to this runner, then you can actually get electricity. That's the reason water turbines, they are used mostly in the hydroelectric power plants. So this is a picture depicting the water turbine. So let's move on to the classification of the water turbines. Depending upon the type of energy available at the inlet of the turbine, they are differentiated into 2 types, namely the impulse turbine. Impulse turbine is nothing but if the energy available at the inlet of the turbine is only kinetic energy, then it is called the impulse turbine. Example being the Pelton wheel. And reaction turbine, if it consists of both pressure energy and kinetic energy, which is available at the inlet of the turbine, then you can call it as a reaction turbine. The example being the Kaplan turbine. And depending on the head at the inlet of the turbine, it is differentiated into high head, medium head and low head. If the head of the water available at the inlet of the turbine, it ranges from several 100 meters to a few thousand meters, then it is called as high head turbine. Example being the Pelton wheel. Medium head turbine, the head of the water available at the inlet of the turbine, it ranges from 50 meter to 400 meter. So the example being the Francis turbine. And the low head turbine is the head of the water at the inlet, which is, if it is less than 50 meter, then it is called as low head turbine. Example being the Kaplan turbine. Depending on the direction of flow through the runner, they are actually classified as tangential, axial, radial and mixed. Tangential flow turbine means the water which flows along the tangential way or the tangential direction to the runner. Example being a Pelton wheel or Pelton turbine. Axial flow turbine, they mean the water which flows in a direction parallel to the axis of rotation of the runner. Example being the Kaplan turbine. The radial flow turbine, where the water flows in a radial direction through the runner. Radial flow turbines, they are further classified into inward radial flow and outward radial flow turbines. The example being the Thomson turbine and the old Francis turbine. Mixed flow turbine, in which the water flows radially into the runner and leaves axially, which is our modern Francis turbine being the example for that. And depending on the disposition of the runner shaft, they are actually differentiated into 2 types, namely the vertical shaft and the horizontal shaft. Vertical shaft if the shaft is in the vertical position, and horizontal shaft if the shaft is in the horizontal position. So let's move on to the principle of impulse turbine. So principle of impulse turbine is as follows. The rotor of the turbine is made to rotate with the help of a single jet or multiple jets of water, which is impinging on a series of specially designed buckets fitted around its periphery. Here the entire hydro energy is converted into kinetic energy by the passing of water through a pipe called the penstock, and then through converging nozzle to form high velocity free jet of water. Generally it is used in high head plants, but it may also be used in lower heads, provided if the discharge is very small. If it has a small discharge, the example being our Pelton wheel. So let's move on to our Pelton wheel. Before going on to the Pelton wheel, so the Pelton wheel, it is actually a tangential flow impulse turbine which is used for high heads and small quantity of water flow. So it has certain parts. So let's move on to the parts, namely the first part being the nozzle with the spearhead. A nozzle is a passage of varying cross section to the penstock. The nozzles may vary in number depending on the design requirements. Usually the nozzles, they are arranged around the runner wheel such that the water jet emerging from a nozzle is tangential to the circumference of the runner wheel. The flow of water through the nozzle is controlled by a spearhead, and which is operated by means of a hand wheel. This arrangement, it provides a smooth flow of water with negligible energy losses. So you can see this is how this is Pelton wheel. You can see the pump attached over here for the running of the Pelton wheel. So you can see over this pipe actually exerts water, and impingement of high velocity jet stream, it falls on these Pelton wheels. They are actually Pelton cups. It is actually in the shape of a cup. So let's move on to the other part, that is namely the runners and buckets. The runner is a circular wheel with a series of evenly spaced buckets fixed around its periphery. The buckets are shaped like bowl or a double hemispherical cup. The advantage of having double cup shaped buckets is that the jet of water gets split and leaves symmetrically on both sides of the buckets. This helps in the elimination of the end thrust or axial thrust on the bearing, and to get a good output shaft through our rotating shaft. The flow of water is actually, I have shown here, right? The flow of water, it actually flows like this. The impingement of water, and it actually high water, it flows like this. And then there is called a turbine casing, which is nothing. The casing, which it prevents the splashing of water, and also it helps to discharge the water into the tail race. So let's move on to the working. In operation, the water from the reservoir having potential energy, it flows through the penstock and enters the nozzle. As water flows through the nozzle, the potential energy of water is completely converted into kinetic energy in the nozzle. The high velocity jet of water issuing from the nozzle impinge on the curved blades fixed around the runner wheel. The impulse force due to the high velocity jet of water sets the runner wheel into rotary motion. Hence, the shaft coupled to the runner wheel also rotates, thereby doing the useful work. Thus, the potential energy of the water is converted into mechanical work. After performing work, the water is freely discharged into the tail race. The work produced at the output shaft is used to drive a generator to produce electricity. The electricity is then transmitted to a substation where transformers increase the voltage to allow transmission to homes, office and factories. So this is the total setup of a Pelton turbine. You can see the electrical apparatus over here. You can see the bowl which is kept over here, and you can see bowl or the beaker which is kept over here, and you can see the number of pipes and all. This is actually that was the Pelton turbine with the usage of electric rotors. This is the Pelton turbine which is by the usage of pumps or just by the usage of mechanical work. You can see the pump over here. This is also a Pelton turbine. You can see the Pelton wheel which is present over here. So let's go on to the principle of reaction turbine. The reaction turbine, it consists of a submerged runner. It operates with its runner submerged in the water. Here only a part of water brought from the source is converted into kinetic energy, and the rest remains as pressure head. Water from penstock is made to flow to the runner at high pressure through stay vanes and guide vanes. Then pressure decreases and reaction pressure exists, As a result, the runner rotates. After doing the work, the water is discharged to tail race through a draft tube. The example being the Francis turbine and the Kaplan turbine. Let's move on to our Francis turbine. Francis turbine is a mixed flow reaction turbine used for medium heads. So medium quantity. The construction is as follows. It consists of guide vanes, upper and lower steerings, and each guide vane which is made to rotate about its pivot center with the help of an individual link and lever. The runner is supported by a drive shaft or a regulating shaft. The guide vanes operate similar to the engine valves, allowing only required quantity of water. The runner is enclosed in a spiral casing or a scroll casing. The exit end of the runner is connected to the small end of the draft tube. The big end of the draft tube is submerged deep in the tail race. Hence, the entire water passage right from the head race up to the tail race is totally enclosed. So this is the total Francis turbine with the usage of an electric rotor. So the working, the water from the penstock, it is actually brought down to the turbine at high pressure through a spiral casing. It enters into the steerings. The stay vanes, they pass the water smoothly and radially to the guide vanes. The runner thus surrounds completely with water. During the process, the pressure actually decreases. Thus, a difference of pressure between the guide vanes and the runner exists, which drives the runner. The movement of the runner is actually affected by both pressure and kinetic energy of water. After doing the work, the water is discharged into the tail race. Axial discharge axially from the center of the turbine through a draft tube. So this is the Francis turbine without the usage of electric rotor. Let's move on to the Kaplan turbine. The Kaplan turbine, it actually has two views. So here the runner is called the boss or hub. It resembles a ship propeller. It is the extension of a vertical shaft, and there are a number of guide vanes which are enclosed in a guide wheel. The runner is enclosed in a spiral casing or a scroll casing. The runner vanes are fixed around the circumference of the boss, that is the runner, and then the exit of the end turbine is actually connected to a draft tube. The big end of the draft tube is opened into the tail race. So you can see this is actually the Kaplan turbine. You can see over here this is actually very big. It consists of very big amounts of pipes or very big radius of pipes or diameter of pipes. So what is the working? Working is actually similar to that of the Francis turbine. The water from the penstock, it is actually brought down to the turbine through a spiral casing. The water flows through the turbine passing from the guide vanes after taking a 90-degree turn. 90-degree turn, have a note of it. 90-degree turn in the axial direction. The guide vanes, they pass water onto the runner vane smoothly. As a result, the boss rotates or the runner rotates. The speciality of this turbine is the runner vanes and their motion, which facilitates the smooth flow of water. The specially designed vanes, they also facilitate the smooth flow of water through the tail race and through the draft tube while the runner is still in motion. The smooth flow of water also flows through the draft tube while the runner is still in motion. So that is a plus point of the Kaplan turbine. So this is a Kaplan turbine with the electric rotor motor. You can see here they actually consist of very big diameter pipes when you compare it with the Pelton wheel or the Francis turbine. So thank you guys. Any questions? Please leave those in the comments box below. You can find me on the Unacademy user platform which is mentioned over here. And please do rate this course, review this course and recommend this slide or lesson if you have liked it. And please do follow me or see my set of courses in the Unacademy user platform which is mentioned over here. Thank you guys. Have a wonderful day.